So, ladies and gentlemen, good morning. It's very nice to see you all. My name is Hans Koel, and in the name of Proact Estonia, I'm honored to introduce today the public lecture by Mr. Bob Plumridge. Data storage now and the future. Mr. Bob Plumridge is also the chairman of SNIA Europe, the organization that promotes technology, sets standards, and also provides education. The world is changing. New ideas evolve or die. In order to be successful, you have to be big enough, like General Electric or IBM or Hitachi, or to focus on certain areas of competence. Yesterday and today in the Tallinn Technical University was held a conference on cybercrime. And Center of Cybercriminalistics and Cybersecurity will be established. It is a joint effort of several ministries: Ministry of Defense, Ministry of Internal Affairs, Ministry of Justice, and other public state structures. Now come to the play other organizations like, for instance, Proact Estonia or Hitachi Data Systems, who actually provide the infrastructure for saving the data that the others protect. Well, new ideas. Are we in the process of revolution in technology, or just evolution? Are there new business models popping up, or is it just marketing stuff? Maybe Bob Plumridge will explain us a little bit further. Bob Plumridge is also the Hitachi Technology Chief Officer of Europe, so he is a technical guy, so please prepare your questions after the lecture. But now I pass the word to Mr. Plumridge.
Thank you. Thank you very much. Good morning, everyone. As Hans has said, I'm Bob Plumridge. I work as the Chief Technology Officer for Hitachi in Europe, Middle East and Africa. I've worked for Hitachi now for about 25 years in various roles. My original background was aircraft instrument design. That's what I did at university, and that's what I did for a number of years until I joined Hitachi, as I say, about 25 years ago. So today, I'm going to talk about Hitachi Data Systems, who we are, what we do. I'm going to talk about overall market trends in the storage arena, what's happening in the storage business, why we're seeing such huge growth, what we think are going to be the major trends over the next 4 to 5 years, and how we think that's going to change business. I'll then talk a little bit about pure technology, some of the underlying technology that we're using to develop some of these high-performant and highly available and storing huge amounts of data and ever-increasing amounts of data. And then I'm going to talk about big data itself. Big data is relatively new in the market, in as much as we've only really been talking about it for the last year or 18 months. However, we've already seen a significant number of big projects that are using big data in an analytical space. And we're already starting to see some of the benefits of doing this, specifically in healthcare. We have a very large project running in the UK at the moment with the British government around using big data and analytics to try and improve the overall health of the population. And I'll give you a little bit of detail on that and how that's working. Another big project is around automotive and transport platforms, such as trains, such as cars, And also that will enable me to talk a little bit about data privacy, because as you may know and may have read, one of the problems with big data and making big data available almost freely is that it does start to impinge on our individuals' right to privacy, because there's a huge amount of data out there, and we're now starting to see some organisations take what some of us may see as our private data and sell it to other organisations. And then we become the recipients of their targeted marketing based on the data that's been supplied to these organisations. So there's a wide remit here, if you like, everything from base technology to data and the use of data and around our privacy and what we have a right to expect in the future, I think. I'm more than happy to take questions. So if anyone has questions as we go through, more than happy to discuss individual points. If you want to save the questions to the end, that's also fine with me. I have no problem either way. So as you may know, Hitachi, Japanese organisation, been in existence for about 110 years. This is our current business, if you like. We're about a $100 billion organisation split across a number of different businesses. I work for this Information and Telecommunications Systems Group, which is about 18% of the overall business. But although we contribute 18% of the overall revenue, actually we get 25% of the R&D funds. So in terms of our fair share, we get more than our fair share of the R&D budget within the organisation, which again is, I think, indicative of how Hitachi see the overall business moving, far more IT, far more technology based. One of the interesting things, though, is that we also supply IT systems for every single one of these other divisions. And if you look at something as basic as construction machinery, one of the interesting things that's happened in the construction world is big data. All of the construction machinery that Hitachi now build and sell into the marketplace, such as equipment to build motorways and build huge skyscrapers, all of those machines now provide big data. Monitored on those machines second by second are things like water temperatures, oil pressures, oil temperatures, the load that that machine is carrying, the environment in which that machine is operating. Is it working in the desert at 55 degrees centigrade, very high humidity, or is it working in the Arctic Circle? That data is being collected second by second from these machines and then is being analysed to look at reliability. If we see a drop in oil pressure, does that mean the engine's about to fail? Therefore, we want to shut the engine down before we have a catastrophic failure. Because replacing an engine on one of these machines, we're talking about several $100,000. And we're also talking about 2 days where the machine cannot be used. So we're using this data for predictive analysis. Because, as I say, the costs involved with this type of breakdown are huge. And everybody wants to run everything 24 hours a day, 7 days a week. Very similar in the automotive division. We're working currently with a very large German car manufacturer who are now putting onboard analytics in their high-end cars. What I mean by that is they are now able to tell second by second how fast you are driving that car. They're now able to tell how hard you accelerate in that car. They're able to tell how hard you brake in that car. So they understand more about your driving style and the way you drive that car than you understand yourself. Who do you think is interested in that data, apart from the car manufacturer? Well done. The police are very interested in that data. No need to speed cameras, no need for policemen out there with speed guns, watching how fast you're driving. The data comes out of the car. They know when you've broken the speed limit, speeding ticket in the post or in the email. Who else do you think might be interested in the way that you drive your car? Insurance, absolutely. So now, as I'm sure many of you know, insurance is dependent on your gender, your age, and your driving experience. Well, if they can actually look at the way you drive, maybe that can change. Maybe your insurance rates will be based on the way that you drive, rather than your age or your gender or your experience. But do the car manufacturers have the right to sell that information about you as an individual to your insurance companies? Without your consent? This is a very good question, and one that hasn't really been answered satisfactorily yet. And I think one of the problems we're seeing is that technology is often running a long way in front of what may be put into law or may be passed by the EU. Again, I'm sure many of you are aware that the EU is currently looking at the whole issue of data privacy. But in English, we would say this is shutting the door after the horse has left. Technology is 5 years in front of what the EU are currently legislating for. And so they're just two very small examples, and I'll talk more about healthcare in a minute or two, because that sort of straddles both boundaries quite nicely. So this is already going on. This is not something that's going to happen in 2 or 3 years. This is happening now. We as an organisation, about 8,000 employees within HDS. Our design development teams are about 7,500 people. Of those, there are about 6,000 dedicated engineers. We have manufacturing, design, development centres based across all of the countries listed there. We also have sales offices and support offices distributed throughout the entire world. Incidentally, Hitachi worldwide, we employ about 320,000 people, so a huge organisation. Increasingly, the areas where we focus, some of I've already mentioned, around consulting, health and life science. This is a huge division and growing extremely quickly. When you start looking at some of the possibilities of big data and how it can be used to improve our health, some of the possibilities are quite staggering. And as I say, I'll talk more about that later. We've talked a bit about transport and machinery. I'll just tell you one more story around transport. Again, I'm afraid this is a United Kingdom story, but in the UK, the British government, about 6 months ago, signed a contract with Hitachi to replace a lot of the old train systems that we have in the UK, some of which are approaching 40 years old. The contract was won by Hitachi. The contract is for 27 years. Part of that contract is that Hitachi will build 2 factories in the UK to manufacture the trains. What's interesting, though, is that the British government are not buying the trains from Hitachi. The trains themselves will remain the property of Hitachi. The way those trains will be paid for is based on reliability and punctuality. So if we run the trains reliably and we run the trains on time, we get paid. If we don't get paid. So as this has been called trains as a service. Sorry.
How is it measured? Punctuality?
So how is it measured? It's measured by big data. So all of these trains, for those of you who may not know, Hitachi build the bullet trains in Japan. So the bullet train system, the Shinkansen system, is a 100% Hitachi product and has been for the last 15 years or so. All of the trains have onboard sensors, GPS. So just as I explained with the cars, they know exactly how fast the trains are going, they know exactly where they are within the network, they know what the schedule should be, they know how far behind or in front they are of the schedule. The trains are also covered with sensors. These sensors, just like the construction machinery, are picking up all the data coming off the train, things like vibrations. Are they starting to see vibrations on a particular wheel set, which may indicate that that wheel set is about to fail, therefore you need to take the train out of service and replace it before we have a breakdown. So this is how it will be measured. The value of the contract is obviously runs into hundreds of millions of pounds over 27 years. The guarantee also from Hitachi is that they will provide employment for 2,500 people within the 2 factories. that are currently being built in the UK. So this is a changing business model, a changing way in which we sell technology and we use technology, and also a change in the way in which we monitor the reliability and punctuality and then deliver against the service level. The days of selling somebody a piece of equipment for £1 million or €1 million and putting the £1 million in the bank and then worrying about the next contract are rapidly disappearing. And I'll explain a bit more about that in a second or two. So, and this is what I mean by market shifts. We are seeing a huge shift away from capital expense models to operational expense models. So people paying for technology as they consume the technology. So our customers now, in a lot of cases, if they use 500 terabytes of storage today, they pay us for 500 terabytes of storage today. If tomorrow they use 400 terabytes, they pay us for 400 terabytes. So we have a changing business model, a flexible model in terms of payment. 5 years ago, you would have paid for everything up front, whether you used and consumed that technology or not. This is a very big change in this industry, and it's now starting to ripple out across the entire world. We also see a big change in the way we go to market, services, direct, indirect. We've seen a huge change in our overall market, the way hardware has moved to software. We're starting to move into what we call a software-defined world, and I'll explain that in a bit more detail in a minute. And also the analytics of this huge amount of data that everybody is starting to store is becoming key. You know, there is no point in storing huge amounts of data if you are not going to use it. Storing data is not free. It costs companies huge amounts of money to store data for very long periods of time. There is no point in doing that if there is no value in the data. If you can't improve your business, if you can't make your business more efficient, if you can't make healthcare services better by using that data, you might just as well throw the data away and save the money of storing it. And we have a lot of people inside the industry and also in a lot of our users who seem to have the idea that storing data for long periods of time for no good reason is a good thing to do. Well, I'm afraid it's not. And I'll explain how we've got into that mess in a minute or two. This is just some of the bigger customers that we do business with across Europe. Obviously, one of the biggest ones being BMW. We supply all of BMW's technology, IT technology for them worldwide. And we also manage all of their infrastructures for them. So a huge, prestigious win for us. So I wanted to just spend a few minutes talking about some of the major trends we see and building on some of the things I've already said. And I'll start with this data growth. As I said, I've worked for Hitachi for 25 years. I've been showing charts like that for 25 years. The speed of growth of data storage is accelerating, not slowing down. We are storing more data on more things than we have ever stored before. In a minute or two, you'll see a number that says by 2018, we will be storing 400 exabytes of data per day. Now, I don't even really know what an exabyte is. It's so huge, it's unbelievable. But 400 exabytes a day, there isn't 400 exabytes of digital data in the world today. And every single one of us are contributing to that, whether we know it or not. We know we are when we use Twitter, we know we are when we use Facebook, we know we are when we use some of the other social media and we upload photos. But if you're in London, for those of you that have been to London, if you've been in London and walked around London streets, just by the mere act of walking down a London street, you are creating data. Because everywhere you go in London, you will be on a CCTV camera. And every single one of those CCTV cameras is storing data about what you do and where you go. And that data, as a minimum, is stored for 10 years. And has anyone heard of facial recognition software? One or two of you. So they can now take your photo and automatically match it across all of those CCTV cameras for the last 10 years. So if you live in London, they know more about your movements than you know about yourself. And of course, this is all done, supposedly, to prevent terrorism. But unfortunately, we all have suspicions about what it's really used for. So this data growth is huge. What is also fueling the growth of data is we now store data for longer periods of time than we've ever done before. Again, if you look at the EU and you look at regulation around the finance industry, around banks, insurance companies, before the financial crash, those institutions had to keep data for 3 years. They now have to keep data for 7 years. That is about to go to 10 years. So in a period of 3 to 4 years, 5 years, we've seen a 300% increase in the length of time the data has to be stored for. So instead of deleting the data after 3 years, freeing up storage space and storing more data, they now have to keep it for 7 going to 10. In the UK, our health service have to keep my healthcare records, my digital healthcare records, for as long as I live, plus 5 years. So the average age for a man in the UK now is approaching 80. So if I live to be 80, they have to keep my digital healthcare records for 85 years. We have a population of approximately 63 million people in the UK, so you can imagine how much data that is. But that's not the biggest problem. We have never done this before. And do you know why we've never done this before? That's one thing, but there is a more fundamental reason, and most of you are far too young to know it. But the storage industry, so the commercial storage industry, has only existed for 58 years. Magnetic disks that we use, still mainly for storing data, were invented and first put into a commercial environment by IBM in 1956. So that's 58 years ago. So we're now talking about storing data for longer periods of time than the storage industry has existed for. So that's why I'm confident we've never done it before. But there's a bigger problem, a much bigger problem. If I could magically bring from a museum one of those disk devices that were in use in the late 1950s or the early 1960s, and we could make it work, do you think you could read any of the data that was stored on that machine 58 years ago? No. Of course not. So we've already failed to store data for 58 years, and now we think we can store data for 100 or 1,000 years. We've never done it. There's an even bigger problem. So if I could take some of that data and we could read that device from 58 years ago, and I could put the data on a 5.25 inch floppy. Anybody old enough to remember 5.25 inch floppy disks? Completely useless. Nobody's got a device that can read that. Even if I could put that data on a memory stick and give it to you, do you think the way in which we store data and the way in which the format in which data was stored 58 years ago is in use today?
We wouldn't have even applications that were used to create the data.
Absolutely. You're 100% correct, sir. And that is the biggest problem. And we can even bring that more up to date. So how many people remember Lotus 123? There's a few of you, nearly as old as me. WordPerfect. Two products that 20 years ago were in common use. If I gave you a Lotus 123 file now, do you think you could do anything with it? You might find something on the internet that would convert it from 123 to Excel or from WordPerfect to Word. But this is only data that was created 20 years ago. If you wind the clock forward another 20 years and say in 20 years' time, 40 years after that data had been created, do you think you'd be able to use Lotus 123? Of course not. In the last 5 years, 2,500 data formats have become completely obsolete. So any data stored in those formats is now completely useless. And this is what we've been doing as an industry. And this is why I said earlier that we still have people with a mindset that believe put data on disks, put data on tapes, put data on optical, and the world will be fine in 50 years' time. Well, I'm afraid it won't be. I'm afraid all they're doing is wasting their money and their time and their efforts, because it will not be any use. And this is a mindset and an education thing that we're currently going through as an industry. So it's easy to state the problem. It's easy for me to stand here and say, nothing works, it's all broken. It's very easy to do that. But at the end of the day, you need a solution. You need something to address that problem and how we move forward. Now, what many of you may have seen and heard of is something called object stores. Now, object stores are still use disks, still use tape, still use optical, still use flash. But the difference here is that the data is not stored in an application format. So if you store an Excel spreadsheet, a .xls spreadsheet as an object, it is not stored as a .xls. It's stored as an HTML file, and what we do is create metadata that describes that file. And this is what the medical industry have been doing for a number of years. Now, there's no absolute guarantee with this, of course, there never is with anything. But by making the data independent of the application that originally creates it, we believe we stand a much better chance of still being able to use that data in 50, 60, 100, who knows, maybe 1,000 years' time. So this is one of the huge changes that's currently going on in the industry. As regulation bites and tightens across almost every industry space, we're seeing more of this type of technology starting to be used. So that's one of the big changes we're seeing. We see huge changes in the number of mobile devices and applications. I should imagine everyone in this room has at least 2 devices that connects to the internet, and many of you probably have 3 or 4. Again, that's been a massive change in the last 10 years. 10 years ago, that didn't really exist. And everybody wants to use those devices all of the time to connect to all of your own personal data. And increasingly what we're seeing is people want to use that for business. So when I have my own iPhone, which is my personal iPhone, I still use that as much for work as I do for private use. I have company confidential information on that iPhone. So what happens if I leave? What happens if I decide I don't want to work for Hitachi anymore and I'm going to go and work for IBM? So we have to have the ability to be able to remotely wipe company confidential information off privately held devices, absolutely. Otherwise the security risks become almost impossible to manage. And as we move more into what's called bring your own device world, which is really where most of us are now, these sorts of things become more and more important. Virtualization, everything is virtualized from storage to servers, VMware, Microsoft, KVM, us. You see more and more virtualization. Really the drive behind virtualization is more productivity, more efficiency, more ease of management, more flexibility in the type of IT solutions that people are able to offer to the market. Huge market growth in that sector. Cloud's been quite interesting. 6 years ago, most people were saying cloud was pure marketing hype. Cloud was nothing. Cloud was nothing more than a new label on something the industry had been doing for 10 years. Turned out they were completely wrong. Cloud has completely revolutionized the industry. Again, it's been a huge change. Hasn't quite worked out the way we thought it would. We believed that by now, most cloud implementations would be public or hybrid. Actually, what we see is approximately 75 to 80% of our customer base have moved to a private cloud, not to public and hybrid. Main reason, security. Most places, it's impossible now not to read anything around the IT industry without reading the latest security breach, or somebody's had their data stolen, or some big supermarket chain has had 100,000 credit card details stolen off of their cloud infrastructure. That's why we see most being private now. Give it another 2 or 3 years, I think the majority will be hybrid based. Even if you talk to a lot of the large banks and financial institutions, their end goal is really to get to a hybrid model. But it's going to take time, and security issues have to be addressed. Convergence. Convergence is an interesting one again. The length of time I've been in the industry, the original converged systems were the original mainframes. We've spent the last 40 years moving away to a completely unconverged world. Now we're moving back again to a converged world. What that really means is a pre-built stack. So having everything built in one or two stacks, applications preloaded, hypervisors preloaded by the manufacturer, the equipment delivered to a customer or a cloud services provider. Typically, the service is in operation within 2 or 3 days. Model 5 years ago was something like that would take 6 months to deliver. But everybody lives in the now world. Everybody wants everything now, not in 2 weeks' time. So really, this is what's driven convergence. As you can see from the numbers, huge market growth in that space. And again, if you look at the industry analysts, you will see that they're predicting that market will continue to grow extremely strongly over the next 5 to 6 years. And what's overriding all of this, and what is, I find, amazing, is that all of this has happened during the biggest economic downturn the world has ever seen. We have seen huge change within the industry. We've seen huge growth. We've seen huge change in the demand from our customers and our partners. Yet, all of the world's economy pretty much has been depressed during this time. And it does sort of make you wonder what's going to happen as we hopefully start to come out of this recession. If we start to see real growth coming back to most of the businesses, these changes are just going to accelerate. So I think we're living in quite an interesting time in terms of developments, both from a technology point of view and from a point of view of being able to use the technology for the growth of business and hopefully for the greater good as well. So hopefully that gives you a quick insight of some of the business side. Don't worry, I'm not going to go through every single one of these, otherwise we'll be here till Christmas. But there is a couple I just wanted to talk about. Predominantly flash and SSD. Again, this has been a huge change in a very short period of time. 4 years ago, as a company, we sold no flash and no solid state. Today, 15% of our total shipments are flash and solid state. And bearing in mind what I said about disk storage going back to 1956, we have always used disk drives. From 1956 up until pretty much now, we have used disk drives as an industry. We are now starting to shift over to flash and solid state technology. Huge change, very different type of technology, delivers huge benefits in terms of performance, but a very, very big change. And also we've seen huge change in the growth of capacity. The first SSD chips we sold about 3.5 years ago, the capacity was 200 gigabytes. The modules today are 3.2 terabytes. So the growth in capacity has been like this. And it has made the growth in capacity of disk drives look relatively slow. And even that has been quite dramatic over the years. We've been used to that doubling every 18 months. But SSD and flash technology has completely outstripped anything we've seen previously with magnetic disks. And then if you add on to that pricing, this is probably the most dramatic thing of all. So there's only really 2 lines to worry about here. This is this orange line, it's labelled MLC flash, and this blue line, which is labelled SAS hard drives. Now SAS hard drives are high performance hard drives. So typically 10 and 15,000 RPM drives. And when you look at the pricing here, you see the prediction is that by 2019, the price of high performance disk drives and solid state technology will be the same. 2 years ago, I was telling people that would never happen. 2 years ago, we were showing similar pricing graphs where these lines didn't cross, even if they came all the way over here somewhere. So in 2 years, we've gone from never to it will happen in 2019. So the reality is it will probably happen before 2019. So what we are starting to see is that this market for the high-performance hard drives is starting to get squeezed. And people are now buying flash and solid-state technology where previously they would have bought high-performance disks. Because obviously flash is better performance, it consumes less power, it puts out less heat, so it costs less to run. And of course you get a 10, 15-fold improvement in performance.
But what about the problem that when a hard drive fails, then you can restore it, but not so easy about solid-state drive?
Well, that's now been fixed. If you look at pretty much all of the solutions now from the major manufacturers, actually solid state to the application and to the operating system or the hypervisor looks just like a disk drive. And if we have a failure in a module, we just spare the module out. And we use RAID, what we call RAID technology, to protect the modules just as the way we did with hard drives. And actually, if you look at some of the reliability numbers now for the latest generation of flash, it's more reliable than any hard drive that's ever been manufactured. And we expect that reliability to continue to increase. Because, of course, one of the big advantages with flash is there's nothing mechanical. A disk drive is a mechanical thing. You know, things spin, things move about. Mechanical things break and will break. Electronics inherently, once they reach a certain maturity level, tend to be far more reliable than anything mechanical. So we expect this to continue. I don't think hard drives are dead. I think we will still have hard drives, but I think the way in which we use them is going to change. And I'll explain that in a second. So this is massive. Now there's something else on here that one or two of you may have spotted, and that's these technologies, ReRAM and PRAM. Two relatively new technologies that currently only exist in laboratories, so they're part of R&D. And what you always, and most of you probably know, is that for every 10 products in an R&D laboratory, one will make it to something that you and I buy. So, you know, with that said, these technologies are already showing huge promise over today's flash technologies. These two technologies may well deliver a 10-fold performance improvement over today's flash technology. So we're at the beginning, we believe, of what we're seeing with flash and SSD right now. We're not even at the end of the beginning, as somebody else said. We're really very near the beginning of this. But now, of course, very expensive, so people wouldn't buy it. But if the pricing of this technology is anything to go by, you know, give it another 10 years and we'll be seeing similar pricing levels. So this is, again, everything from base technology all the way through to the use of the technology is changing very, very quickly. And I said I'd just build this one out. So this is how we expect things to roll out. This is pretty much where we are today. Small proportion of flash, a lot of high-performance disk, and then a lot of big capacity drives for data that needs to be kept for long periods of time with relatively low access. Moving forward, flash market grows, high-performance disk market gets squeezed. Ultimately, we see this part of the market disappearing entirely. These disk drives, the high-capacity ones by then, will be 10, 20 terabyte disk drives. Huge capacity compared to what we have today. What's the problem, though? Yes. If I gave you a 20 terabyte hard drive now and said it's failed, rebuild it, you're looking at probably 20 days to get all the data back onto that hard drive. If you're running a bank, that's probably not a very good idea because you probably wouldn't have very many customers left at the end of it. So there are practical problems with some of these. However, and I can only say this because I'm old, I remember when we moved from 4 gigabyte hard drives to 16 gigabyte hard drives. I had customers say to me, I will never use a 16 gigabyte hard drive because it's got too much data on it, and if it fails, it will take too long to rebuild. So I'm always very reluctant due to my experience and what I've seen over the years, saying customers won't use them. The fact is, every time we release a bigger hard drive, we stop selling the old ones. When we went from 1 terabyte to 2 terabyte hard drives, nobody wanted to buy 1 terabyte drives. When we went from 2s to 4s, nobody wanted the 2 terabyte drives. We're now moving to 6s, nobody wants to buy 4 terabyte drives.
Methods of restoring are changing.
Yes.
With the capacity as well.
You're absolutely correct, sir. Absolutely right. RAID technology, for those of you that know what RAID is, we've been using RAID to protect these drives now for 23, 24 years. We do believe that as we get to these very large drives, RAID technology will not be the way to protect them. There's things called erasure coding being worked on. There's also something called dispersed parity, where you disperse the parity to protect the drives over 1,000 or 2,000 other hard drives, which enables much faster rebuild times. But yeah, so that's something else that's being worked on by most of the industry now. And hopefully we'll have something in place next 9 months to a year, I think, around that, as we get to these really big drives. So huge change. I think I've covered most of those. So I just wanted to talk a bit about how the traditional market's changing. So this traditional market, as it's been for a number of years, I'm sorry these numbers are so small, but what we're starting to see is by about 2020, we'll start to see a move towards this enterprise server stand storage. And what we mean by that is that we see the days of having servers, storage, completely separate, starting to disappear. We see the two things starting to come together. So we've always had this storage has been completely separate from the servers, and we've always been connected by SCSI or fiber channel today, FCOE, FICON for mainframe. We're starting to see that start to change and start to merge. So when you look at software defined, this is starting to drive this, starting to take some of the inbuilt functionality in the hardware platforms and abstract it to a software layer. So we start to see, instead of all the intelligence laying in the hardware level, we're starting to see some of that intelligence moved up the stack, as it were. And the software definition for the data center, for the storage, starting to reside outside of the physical hardware. And that's really what the software define's all about. Now, this term COTS, does anyone know COTS? No. What it stands for is commodity off-the-shelf hardware. Now, in this industry, pretty much everything that's been available is custom built. So the storage arrays are built off of custom platforms, what we call ASICs. We're starting to see a shift to move that off to be designed and built off of x86 platforms. And x86 is commonly referred to as a commodity platform because it's relatively cheap, certainly in comparison to custom designed hardware. Custom built and designed hardware. So this is starting to fuel this growth and this push towards everything being commodity. And I'll give you an example. Again, I'm afraid it's an old one, but I remember getting my very first PC. So I got my very first PC about 25 years ago, before most of you were even born, I guess. That PC was an IBM machine, and it cost £10,000. Can you believe that? £10,000 for one PC. Anybody like to know what the profit margin was on that one PC? 40%. So when IBM sold my company, that PC, for £10,000, they made a £4,000 profit. Do you think they were happy? Yes, of course they were. How much did this one cost? 2 years old, top of the range, 2 years old, so ancient now. Sorry? Yeah, £600 approximately. What do you think the profit margin was?
Probably 5 to 3%.
They would have been very, very, very happy to have made 5%. So in 20 years, 23 years, we've seen profit margins with these go from 40% to 5%, and we've also seen the cost dropped from £10,000 to less than £1,000.
Will Hitachi move to context architecture?
Yes, we will have to. We have no choice. If we don't, we won't have a business. It's as simple as that. It's not if, it's when. And if you look at almost everything that's going on in the industry, you see that that's what's happening. So hardware, I don't care what it is, whatever hardware it is, eventually it moves to a commodity base. So the value is not in the hardware, the value is in the software, the value is in the feature and functionality, the value is in the services that go around delivering the applications that customers need to run their businesses. It's not in the underlying hardware. You know, if you look back, if you look at the history of IBM, for instance, you know, their history as a hardware manufacturer. They survived for 20 years on very high profit margins on hardware. You can't do that anymore. Disk drives. 10 years ago, there were 8 disk drive manufacturers. How many are there today? 2. Seagate, Western Digital. Why? Because the others couldn't make any money. Look at both at Seagate and Western Digital. What are they trying to do? They're trying to get in businesses other than manufacturing hard drives. The profit margins on manufacturing hard drives are so thin you can see through them. There is no money. You cannot run a business manufacturing hard drives anymore. Why do you think IBM sold this business? Couldn't make any money. The value's in the software, not in the hardware. And that is the way this industry is going to go. No doubt about it. Very interesting times. So you've probably heard about the third platform. The third platform basically is what we're using today. Exposure to everything, internet connected to everything, Internet of Things, big data. All of that is around what is now commonly referred to as the next platform, the third generation, fourth platform, third and fourth platform. This just explains what I've already talked about, really. This is the movement from individual platforms to do specific jobs over a period of time to a converged system. So this magic green box, as they're always magic, aren't they, when they're in the future, they will solve every problem you've ever had and everything will work perfectly until we get there. Then there might be 1 or 2 problems. But that's the promise. But this is a revolution over, again, what we've had for the last 20 years in this industry. This is really bringing all of the server and storage technology together in one platform. Some of this is driven just by the sheer amount of data that organisations are carrying. It's not possible to move this data around anymore. It needs to be right where the servers are in order to make use of this data. So I just wanted to, I've got a few minutes left, I think. I just wanted to talk a little bit more about big data, unless there's any questions on anything I've covered so far. No, you're not allowed to ask some questions.
Software tends to move to open source. Well, if even the software business is transferred from the real big makers of software, what's left then?
What's left? Well, I could answer that from a purely personal point of view and say that by the time that happens, I'll be retired. So all of you will be paying my pension, which I'm very grateful for, especially if you're in the EU, which we may not be. On a serious note, it will move towards services. What this industry will move towards is the implementation and the design and development of the applications and the delivery of those applications. The data, the use of the data, the term data scientists, how we use the data. What can that data be used for? The hardware, the software eventually will become, I won't say irrelevant, but they'll start to move down that road. Software will take a lot longer, I believe, than hardware. Hardware is probably the next 5 years. Software will be probably another 10, I reckon. But services industry is where it's going to be, absolutely. So just on this, just to give you an idea of this, you know, we're moving into this machine-generated age. I talked about the trains, I talked about cars. I'm going to show you a couple of examples in a minute of which are really extreme examples of the huge amounts of data that's being generated and some of the things that it's being used for. And again, we're seeing all the traditional companies involved, everybody you would expect, plus maybe some of the not so traditional companies starting to be involved in big data analytics. So Google, Amazon, both have access to huge, unbelievable amounts of data, and they want to use that data to drive their own businesses. So this comes back to privacy. So every time, as we all know, you put something on Facebook, somebody is using that data for something. And the same with Google, the same with Amazon. This data is already being used. That's why I say the horse is already bolted, as we would say in English. So to give you an idea of what we mean here. So 24 hours of data. New York Stock Exchange, very traditional business, been around for a very long period of time, well understood, pretty well run, do about 3 billion share trades a day. That generates about 1 terabyte of data. So it generates less than half a disk drive's full of data. Pretty big business, lots of money involved. Look at Twitter. And these numbers are probably slightly out of date now because they change by the day, I would imagine. 645 million users, 700 million tweets, generating 20 terabytes of data. So it's already 20 times bigger than the New York Stock Exchange. Now, at this point, somebody usually says, yeah, but Twitter's just social rubbish. Most of the data on there is just idle chit-chat and nobody cares about it and nobody stores it and it all gets thrown away. Wrong. Completely wrong. In Japan, the Tokyo Stock Exchange have what they call a sentiment analysis engine. They monitor Twitter for everything that is said about any share prices that are quoted on the Tokyo Stock Exchange. They use that data to adjust share prices on the Tokyo Stock Exchange. That's been happening for the last 2 years. We, as Hitachi, monitor everything that is said about Hitachi on Twitter and every other social network. If somebody says something derogatory or bad about us or complains about our service, we take action. Twitter data is as important to us as customer emails. This is starting to happen across almost every social network. There is a huge amount of analysis going on every single thing you say on Twitter or anywhere else. So that's fairly large. But when you look at machines, it makes what goes on Twitter look tiny. I was, earlier this year, I was at a series of events given by Lufthansa, the German national airline. And I specifically went along to listen to what their CIO had to say about the way in which they were using data. So this was about 6 months ago. 6 months ago, Lufthansa were monitoring real-time fuel consumption on all of their long-haul flights. So anything that flies out of Germany to the US or to Japan or China or Australia, New Zealand, they monitor real-time the fuel consumption on those aeroplanes. Why? What's the biggest cost for an airline? Fuel. If they can improve fuel consumption by 1% on a long-haul flight, that's the difference between that flight losing money and that flight making money. They can now work with air traffic control and the pilots on the plane to make sure that that plane is being flown most efficiently, i.e. best fuel consumption or lowest fuel consumption, maximising their profits, minimising any losses. So that was what they were doing 6 months ago. So out of all that data that comes off all those planes, that's all they were looking at. However, when he started talking about the future, it started to get quite interesting again. He forecasts that by 5 years, black boxes on aeroplanes will be completely obsolete. The amount of data that will be stored on the ground real time from any aeroplane in the air will be far greater than any amount of data that you could ever record on a black box. And of course, what's the biggest problem with a black box? As unfortunately we've only too recently seen.
It's hard to rewind.
In this particular case in Australia, they still haven't found it. They still haven't found the black box after the crash. They have no idea, that they're telling us anyway, of what happened on that aeroplane. And of course the problem then is they've got no way of preventing it happening again because they don't know what happened. So if you can find the black box, you can analyse the data, maybe you can stop it happening again. If you can't find the black box, you've got no idea. So if you don't have to have a black box, you don't have to find it because you've already got the data. So what's the other possibility?
Capacity.
Sorry?
Capacity.
Well, capacity, yeah, but there's another big possibility here. What's the one thing a black box could never do? Sorry? Fix the plane, prevent the crash. It will never prevent the crash that it's recording. But if you're streaming enough data real time to the ground and the analytics engines are smart enough, maybe we can see what's going wrong before the pilots do. Maybe we can help the pilots correct something that would cause that crash.
We don't need pilots at all.
Well, that's a possibility, but I'm not too sure I'd get on an aeroplane without pilots. I don't like getting on trains without drivers, but you know, that's me. But things change. Having said that, as you may know, in the UK, we now have trials running with driverless lorries and trucks. 2-3 o'clock in the morning now, Google are running trials and have been allowed by the British government on certain motorways to run trucks that have no drivers. Staggering, isn't it? Never thought I'd see that sort of thing in my lifetime, I must admit. Absolutely amazing. So the possibilities of this are almost endless. And I mentioned healthcare, so I'll talk about that now as I'm starting to run out of time. We have a big proof of concept running now in the UK with the British government. As I said, all of our healthcare records are pretty much digitised, and now what they're starting to do is looking at our health. We have 3 big health problems in the UK currently. The 3 are heart attacks in men in their 50s, strokes for both sexes, people typically over 55. The biggest one of all is diabetes in young children. We have an epidemic almost on the same scale as the US do of childhood diabetes. And for any of you here who know much about diabetes, you'll know that diabetes is not something you want for a long period of time. The long-term health effects of diabetes are catastrophic in almost every case. It's an awful problem. So what do? The cost of this healthcare is astronomical. We now have a bigger retired population in the UK than we do working population. The average age of the population is going up quickly. People are living longer. Healthcare costs are huge, and that's paid for out of our taxes. So as few of us are working, our taxes are going up to pay for the healthcare of people who are getting older. Now, so you either continue that model and go bankrupt, or you have to do something about it. So, when they looked at this, if you have a stroke in the UK, the cost to treat you is approximately £200,000. That's if you live. If you can prevent that stroke through education, the cost of providing the education is approximately £20,000. So about 10%. So if you can do that on a wide basis, you can save huge amounts of money, but probably the most important thing is you improve people's quality of life. So this is what's going on. So all this data that's been gained and all this data that's been input about our lifestyles and our healthcare is now starting to be used to target individuals. So instead of the government saying everybody in the country should drink less, smoke less, exercise more, have a less stressful job, and of course everybody just completely ignores it, they're trying to target that now at individuals that are at high risk. So the obvious one is heart attacks. You know, if your grandfather has a heart attack and your father has a heart attack, unfortunately, there's a very good chance you'll have one. So you are an obvious target. You are the person that they're going to come to and say, this is your risk. If you don't do X, Y, and Z, this is the likely outcome. So that's what's starting to happen in the UK. Again, based on data collection, based on data analytics. Now, from an education point of view, the important thing here is you have to be able to understand the data. You cannot build an analytic engine to look at data to come up with some very smart answers if you don't understand the basics. So the idea of data scientists in each of these industries is huge. And they're certainly from a UK base at the moment, there is a huge education gap around this particular area. We just do not have enough people with these skills. And they're consequently worth a lot of money. So, there was one last one. And this is the sort of research side. So large synoptic survey telescope, staggering amounts of data. And of course, the other example here is the Large Hadron Collider at CERN, without producing so much data, nobody even knows how much they've got. But what's interesting at CERN is that 80% of the data that comes out of the collider is never recorded because they know what they're looking for. So they know what data they want to keep, and they pretty much know what data they can afford to throw away. So they're already doing real-time stream analysis on the data from the collider around the various experiments that they're running. So I've come to the end of my planned presentation. Any questions? No, stunned silence. Must be time for coffee. No? Okay. Well, so just remains for me to thank you. Thank you for your attention. I've gone through a lot of information, I think, in a relatively short period of time. But I've tried to cover most of the high-level topics.
You said that cloud technology in 5 years will switch from private to hybrid.
That's what we currently believe, yeah.
And can you tell me why is that? What are the advantages?
Oh, okay. Yeah, sure. Sorry. Yeah. So the real advantages to hybrid are public access. So typically, if you look at what a private cloud is inside a company's business, behind the firewall. So you and I, if a bank is running a private cloud, you and I, as their customers, can't get access. But what they want to be able to do is open up part of that so you can have access to the data that you should be able to see, so that you can do transactions in a secure manner, so they can keep the data private for their other customers and some of their other businesses, but allow you to see what you should see. That's really what public cloud is about, or hybrid. So it's a melding of the two. So some of the areas where we see public clouds are typically government services. We see some public cloud there, but not huge amounts yet. Okay? No one else? Okay. So thank you very much for your time, and I hope you found that enjoyable, and hopefully you found it useful and educational for the future. So thank you very much.